Hi everyone. So in this video, I'm going to talk about a question about rational function. So which is features basically. So let's take a look at the question and see what we have. So the question says the ratio of the length of a rectangular floor of a closet to its width is given by this ratio. So this function. Which of the following statements are true about this function in this context? Okay, so be careful with that, because like if there is no background, if you are just given r of x equals x over x minus 8, your domain might be different than this problem. So but now we do have some sort of restriction. Okay, so keep in mind. So since we are talking about the two sides, like one side is x, the other side is x minus 8 of the rectangular floor. So then the length would be the x, the width would be x minus 8. And then these two numbers are the sides of a rectangle, right? So which has to be positive. So which is why I should say x should be larger than 0, and x minus 8 should be larger than 0 as well. From this, I can see x has to be at least larger than 8, because if this is something larger than 0 but it's not larger than 8, you don't really have like positive numbers for the width, which doesn't make sense for this context. So which is why we have to take the domain as all real numbers, okay? That is larger than 8. So you can just say domain is the all real numbers that is larger than this, larger than 8. But 8 is not possible, so keep that in mind. And that's your domain, which wasn't asked, but it's good to know. Okay, so the question is asking the range of the function is all real numbers larger than 8. Um, that's what we want to check. It might be the same, but we'll see that. So the range is the all possible y values, right? So which is why we like to see what are my possible y values. Like we can start with like plugging some numbers just to see how that looks like. But if you choose, let's say, x equals 8, which is you can, because 8 divided by 0 is undefined. But if you choose x equals 9, right? So you will get 9 divided by 1, which is going to be 9, right? So if you choose like x as 9, so you will get 9 over 1, which is 9. So which means your y value could be 9. But if I choose something else, just to see some idea, if I choose, let's say, 10, so 10 over 2 is 5. So your y values are getting smaller and smaller. But how small, which is we have to check. But at least from these two concrete points, we can say that this is for sure not correct, because we already got 5 as one of the y values. If you choose, let's say, like 9 for, actually we already did that. So let's say we choose x to be, let's say, I don't know, 20, let's say 16, right? So if I choose 16, 16 divided by 8, which is going to be 2. So the y value is getting smaller and smaller. So 2 might be the one of those range values, 5 might be, but it's not this one for sure. So this is wrong. Okay. But what is it then, right? Maybe we have to know that as well, which is I will wait a bit until we answer the other two. But that is for sure is not larger than 8, because we see something lesser than 8 is possible. But this next one, the question was asking, the statement's function has a horizontal asymptote at y equals 1. The first thing, so what is this, right? If you don't know about this term, this basically means a line that is horizontal, which is y equals something, that your graph is approaching to, but never touch it, okay? That is the horizontal asymptote. So they may intersect sometimes, but now I'm gonna not dive into that yet, okay? So asymptote is just the line that you're approaching to your graph, okay? But what is it? Like, how do we find it? Like, you can plug some values, which is we were trying, like we start with 9, and then like we got 9, 10, 5, 16, 2. Maybe if I try like 20, like 5. So let me try that. So 25. And maybe I should make a table, but that's fine. So 25 over 17. But That's not really nice number. So let me choose something better number looking. So if I choose, let's say x to be 24, right? If I do this, like you will get 24 for x, which is not that nice either. But 24 minus 8 is 16, so you will get 24 over 16. If you divide 24 and 16 by 4, or actually 8, so you will get 3 over 2, which is not too bad. But this is 1.5, which is still smaller than this. Your line is actually getting closer to a number, but it looks like getting maybe closer to 1. So let's see if this is the case. How do we check that, right? So there are a couple ways. Let's say you choose the, let me do this. Okay, so let's say you choose some, that's not great. Okay, so let's say you choose some x values that is getting bigger and bigger because the domain was getting bigger and bigger. If you are allowed to, we choose these numbers, right? So if I choose, let's say, I don't know, 100 for x, so you are going to see 100 over 92. 100 over 92. But this is still larger than 1, right? So 1 point something, you can just see that, but you can plug in calculator to see it. If I choose like 1000, so you will get 1000 over 1000 minus 8, which is 992. So if you were to like plug these numbers in calculator, so let's see what we have, right? And see if that's gonna give us some idea. So 100 over 92 looks like 1.08. Okay, so 0.8, 6. If I do 1000 divided by 992, I will get 1.0080 and stuff like that. But we start with 9, and then we were like keep getting smaller values for the y values when you choose x to be larger and larger. So if you just continue in this, your y value is looking like approaching to 1. That's why we say that's the asymptote. What does that look like? Which is we are going to see in the graph. But if you choose x to be larger values, your y is actually getting some like closer to 1. But do we really need to do this much work to see if that's really the case, or is there another way? So there is another way, which some of you already know. So when you have a rational function, which is we have, so you take a look at the coefficient of the largest term, which is 1, coefficient of the largest term, this is 1. So you divide this by this if the power of these like the variable is the same. So this is x to the first, this is x to the first. If the power of these two guys are equal, which is the case, then the coefficient of this guy divided by the coefficient of this guy is your horizontal asymptote, which is 1 over 1. So that will be equal to y equals 1 is indeed our y-intercept, like horizontal asymptote, okay? So let me draw that. So I will have something like this. Okay. So the line that will pass through is y equals 1, right? So this is my horizontal asymptote. The meaning that my graph shouldn't be touching this one. It will be getting closer to this one, okay? So y equals 1. That's my horizontal asymptote. The next one is function has a vertical asymptote. Some people may know already immediately from the function itself, but if you don't know, so it's basically the line that you cannot touch. You just need to get close and close, and that will happen if your denominator is 0. Why is that? Because like if you have a number divided by 0, that means that is undefined, so you cannot have any like value for that function. There is no y coordinate. When this is going to happen? When you have denominator is 0, so which will be 8. So if you choose x to be 8, 1, 2, 3, 4, 5, 6, 7, 8. So you will get as your vertical asymptote. Okay, so let me repeat again. So you do get the vertical asymptote at the points that will make the denominator 0. There are some exceptions when you have whole, but for now we don't have anything like that. So that is x equals 8. So your graph will be getting closer to this guy when you choose x to be as large values. And then your graph will be getting closer to this guy. Okay, so when you choose like any x values that is large, like getting closer to like basically 8. Because if you get closer to 8, like you can assume that if you choose like 8, that will be 8 over 0, which is not okay. But if you choose 9, 9 over 1 is 9. So it will be like 9 comma 1, something like this. Let me write here. So this is 9 comma 1. If you choose like, let's say 10, so 10 over 2, which is 5. So when you have 10, so you will be getting 5. So let me try that. So this was 10. When you choose 10, that will be 10 over 2. Actually, no. Actually, yeah, that was correct. So if you choose 9, so 9 over 1, that's 9. But I choose 1, so that was wrong. So let me fix that. So if you choose x equals 9, so if you choose x equals 9, which was 9, right? So this was 9. So if you go somewhere here, so let's assume this is 9, and that's 1 point. If you choose 10, so 10 over like 2, which is gonna be 5, so that will give us something right there. And if you choose something more, like let's say if you wanna choose 11, so maybe 11 over 8, which is like maybe getting smaller and smaller, 3 point something. We already know 16 comma 2, 24 comma something. But as I mentioned, your graph is going to be getting closer to x equals 8, okay? When you're getting closer to 8, right? So, which is why you are going to have something like this. At the same time, we are going to have getting closer to this line, when your x values are getting bigger and bigger. So because your y value is getting closer to 1 when the x is too big. So it will be something like this then. So again, this is not the best curve, but it will at least tell us how the graph will look like. And then this will continue like this. And you are gonna getting closer to this line. You are gonna getting closer to this line as well, if you were to draw this. So this is the graph in the positive area, but there is a negative version of this part somewhere right here, which I will not graph it because in our question, we are looking for the answers in this given context, which means the length and the width has to be positive. So if I want to draw this only, that should be it, okay? Which question didn't really ask, but it's good to see how that looks like. And if you were to have the negative part as well without having this context background, only this function, so you will probably get something like this. I'm going to leave that for you to explore. But this is also correct. So we have 2 and 3 is correct. So I hope this is a reminder or something you learn new. So about the graph of the rational function and asymptotes, okay? So I'll see you in the next video.